What makes Proxima B so extraordinary is that it's an Earth-like planet, but there's something even more remarkable: it's orbiting the closest star to our Sun, Proxima Centauri. This isn't just any exoplanet, it's potentially the most accessible Earth-like world we know, located just over 4 light-years away in the vast expanse of space. Imagine that, another world, so similar to our own, sitting in the shadows of our cosmic neighborhood, offering tantalizing possibilities about what might lie beyond our home planet. While Proxima B may not be in our solar system, it represents a far closer neighbor to Earth than anything we could have ever imagined. And now, with the help of the James Webb Space Telescope, we're getting closer than ever to understanding what makes this distant world so fascinating. The star that Proxima B orbits, Proxima Centauri, is the closest known star to the Sun, just 4.24 light-years away. But don't be fooled by its proximity. Proxima Centauri is a faint red dwarf, significantly smaller and cooler than our Sun. It's part of the Alpha Centauri system, a triple star system that also includes Alpha Centauri A and B. This red dwarf is so faint that it's nearly impossible to see with the naked eye, but that hasn't stopped astronomers from studying it. In fact, Proxima Centauri has become the subject of intense interest in recent years, thanks to advances in technology that allow astronomers to peer deeper into space, examining stars and their planets in much greater detail. While Proxima Centauri was first discovered in 1915 by Scottish astronomer Robert Innes, it wasn't until the early 2000s that astronomers started noticing something strange: the star was wobbling. To the untrained eye, this might have seemed insignificant. But for specialists looking at the distant reaches of our galaxy, these small shifts in the star's position were telling a different story. The star's wobbles hinted at the presence of unseen planets, tugging on it with their gravity. These subtle movements became more pronounced over time, signaling that Proxima Centauri wasn't just a star, it was home to an entire planetary system. In 2016, astronomers made the groundbreaking discovery of Proxima B, a rocky exoplanet located within the habitable zone of Proxima Centauri, the area around a star where conditions might be just right for liquid water to exist. But here's the thing: astronomers didn't actually see the planet directly. Instead, they used a clever technique called radial velocity, which involves measuring tiny changes in the star's light spectrum as it moves in response to the gravitational pull of an orbiting planet. These subtle shifts were detected by sensitive spectrometers on ground-based telescopes, like the Laser telescope in Chile, which provided the first hints about the planet's mass, orbit, and distance from its star. Despite this exciting discovery, we still knew very little about Proxima B. Ground-based telescopes could provide basic information, such as the planet's mass and its proximity to Proxima Centauri, but we lacked detailed data about its atmosphere, surface conditions, or potential to support life. This is where space-based telescopes come in. The James Webb Space Telescope, launched in December 2021, was specifically designed to push the boundaries of what we could learn about distant exoplanets, like Proxima B. By operating in infrared wavelengths, Webb is able to peer through the cosmic dust and gas that often obscure our view from the ground, giving us an unprecedented look at distant worlds. Webb's advanced infrared capabilities have already started to yield incredible results. While previous telescopes like Hubble could only study the universe in ultraviolet, visible, and limited infrared light, Webb is equipped to look much deeper into the infrared spectrum. This is essential because many objects, particularly distant galaxies and exoplanets, emit light in wavelengths that Hubble and other telescopes couldn't detect. But by looking in the infrared, Webb allows us to peer back into the distant past of our universe, seeing galaxies as they were billions of years ago, in their infancy. However, it's not just galaxies Webb is after. One of its most intriguing capabilities is the ability to study the atmospheres of exoplanets in detail. Through a technique known as light spectroscopy, Webb can analyze the light that passes through, or reflects off, a planet's atmosphere. By doing this, astronomers can identify the chemical composition of the atmosphere, whether it contains water vapor, methane, carbon dioxide, and other gases that are crucial for life as we know it. This breakthrough has opened a new chapter in the search for extraterrestrial life. Webb can now detect the biosignatures that could hint at life, making it one of the most important tools in the quest to answer the age-old question, are we alone? Now, let's turn our attention back to Proxima B. This rocky planet orbits its star at a distance of just 7.5 million kilometers, about 4.7 million miles, a mere 5% of the distance between Earth and the Sun. This might sound dangerously close, but because Proxima Centauri is so much cooler and fainter than our Sun, the planet receives a similar amount of energy to Earth, despite being much closer to its star. This places Proxima B in the habitable zone of its star, a sweet spot where liquid water could exist. But here's where things get complicated. Proxima B is likely tidally locked, which means that one side of the planet is always facing its star, while the other side is perpetually in darkness. The result? Extreme temperature differences between the two hemispheres. The day side could reach scorching temperatures of up to 400 degrees Celsius, 752 degrees Fahrenheit, while the night side might be frozen solid. However, all is not lost. Proxima B's atmosphere, if it exists, could help moderate these extreme temperature differences. The terminator zone, the area where the day side meets the night side, might offer more temperate conditions, potentially allowing life to thrive in this narrow band. But there are additional challenges. Proxima Centauri is an active star, prone to powerful solar flares that could strip away the atmosphere or expose the planet's surface to harmful radiation. Still, if Proxima B has a strong magnetic field or a thick, protective atmosphere, it might be able to shield itself from these harmful effects and sustain life. The discovery of Proxima B has shifted our thinking about where life might exist in the galaxy. For years, astronomers focused on planets orbiting stars like our Sun, mainly because they assumed that life could only exist around stable, Sun-like stars. However, Proxima B and other planets around red dwarfs challenge this assumption. In fact, red dwarfs make up about 70% of the stars in the Milky Way, meaning there could be countless more planets in the habitable zones of these stars, just waiting to be discovered. For now, Proxima B remains one of the most promising candidates in the search for extraterrestrial life. While direct exploration is still far beyond our current capabilities, advancements in space travel, such as nuclear fusion propulsion or solar sails, could one day make a mission to this distant world possible. In the meantime, the James Webb Space Telescope will continue to uncover new information about this intriguing planet, bringing us closer to answering the question, could Proxima B be home to life? One of the most compelling aspects of Proxima B's potential habitability is its extreme environment. While the planet's proximity to its star makes it seem inhospitable at first glance, life on Earth has shown us that organisms can survive in some of the most extreme conditions. In the depths of Earth's oceans, near volcanic vents, extremophiles thrive in conditions of extreme heat, high radiation, and crushing pressure. These life forms, such as tardigrades, which can survive in the vacuum of space, demonstrate the incredible adaptability of life. If Proxima B has subsurface oceans or volcanic activity, similar to Earth's deep-sea vents, it could provide a stable environment for microbial life. Even if the surface conditions are extreme, life might find refuge in these hidden, more stable environments. Whether life on Proxima B would resemble the extremophiles we know on Earth, or whether it would take on a completely different form, is a mystery waiting to be solved. In conclusion, the discovery of Proxima B has not only sparked interest in the potential for extraterrestrial life but has also opened a new chapter in our understanding of habitable worlds. As we continue to study Proxima B with advanced telescopes like James Webb, we're one step closer to answering one of humanity's greatest questions: are we truly alone in the universe? Whether